students, today our class is about units and measurements part 2. Let's revise our previous class. First of all, what is a measurement? Measurement is comparison of any physical quantity with its standard unit. Measurement is a basic of all scientific studies and experimentation. It plays an important role in our daily life, like measurement of mass, measurement of volume, measurement of length, measurement of temperature, and etc. So, it plays an important role in our daily life. For example, when you can measure what you are speaking about and can express it in numbers, you know something about it. But when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. So, first of all, let's discuss what exactly is a physical quantity. In physics, a physical quantity is any physical property that can be quantified. So, that can be measured using numbers. Examples of physical quantities are mass of a person. Okay, we say mass of a person is 65 kilograms. Length of a table is 3 meters. Area of hall is 100 square meters. Okay, temperature of a room is 300 kelvins. So this is about physical quantities. Okay, so physical quantities may be divided into two types. First one is fundamental quantities and second one is derived quantities. Fundamental quantities. What are these? The quantities that do not depend upon any other quantity are called as fundamental quantities. So these are base quantities, right? Example, mass, time, length and temperature. Next is derived quantities. The quantities derived from the fundamental quantities are called as derived quantities. For example, area. So area is length into length. So length and length are the fundamental quantities. When you multiply length and length, you will be getting area. So derived quantities are the quantities which are derived from the fundamental quantities. Okay. Next is about units. So what exactly unit is? Let's discuss. The process of measurement is basically a process of comparison. To measure a quantity, we always compare it with some standard reference. Okay. For example, when we state that a rope is 10 meters long, it is to say that 10 times as long as an object whose length is defined as 1 meter. Okay, I am repeating it again. It is to say that it is 10 times as long as an object whose length is defined as 1 meter. Such standard is known as a unit of the quantity. Hence 1 meter is the unit of the quantity, that is length. Okay, so that's about unit. The units in which fundamental quantities are measured are called as fundamental or base units, and units of measurement of all other physical quantities which can be obtained by suitable multiplication or division of powers of fundamental units are called as derived units. Okay. So let's study about, we have discussed about different characteristics of units. They are well defined, suitable size, reproducible, invariable, indestructible and internationally acceptable. These are the different types of measurement systems. First one is CGS system. CGS, it is based on centimeter, gram and second as fundamental units of length. So length for centimeter and mass for gram and time for second. So a complete set of units which is used to measure all kinds of fundamental and derived quantities are called as system of units. Okay. So one of the common type is CGS system. Second one is MKS system. The MKS system is based on meter, kilogram and second as the three base units for measuring length, mass and time respectively. Next one is FPS system. Same way, F stands for foot, P stands for pound and S stands for Second. Next is International System of Units. What is this? SI unit of system. The system of units used by scientists and engineers around the world is commonly called as metric system. Okay, this system is the International System of Units and abbreviated as SI. Okay, so the SI unit of system contains 7 fundamental units and 2 supplementary units as discussed. These 7 fundamental units are length, mass, time, temperature, electric current, luminous intensity, and amount of substance. We have discussed definition of each fundamental unit in detail in the previous class. So these are the 2 supplementary units, radians and steradians. Okay. So we have already discussed different rules for writing SI system of units, like they should not have any plural form, and there should not be any full stop after the unit, and etc. Okay. So some practical units for measuring length. 1 micron. Okay, 1 micron, it is the unit of length, and 1 nanometer is also a unit for length, but our standard unit is meter. System of international units, our standard base fundamental unit for length is meters. So 1 micron is how many meters? 10 to the power of minus 6 meters. If I say 1 meter is equal to how many microns, then it will be 10 to the power of 6 microns. Next, 1 nanometer is 10 to the power of minus 9 meters. So microns are generally used for measuring smallest lengths of the particles like bacteria, and nanometer is for measurement of length of the molecules. And 1 angstrom, 10 to the power of minus 10 meters, and 1 Fermi is equal to 10 to the power of minus 15 meters. Again, 1 astronomical unit. What exactly 1 astronomical unit is? It is defined as the mean distance of the earth from the sun. So generally the distance from the earth and sun is measured in astronomical units. Astronomical unit is the length for measurement for length. Okay, so 1 astronomical unit is 1.5 into 10 to the power of 11 meters. So generally this is used to measure the distance between planets. Next, 1 light year. Light year is also the unit for measurement of length, and it is the distance traveled by light in vacuum in 1 year. This is the what exactly 1 light year is. It is the distance traveled by light in vacuum in 1 year. So 1 light year is equal to how many meters? It is 9.5 into the 10 to the power of 15 meters. So where light year is used is, it is used to measure the distance between stars. Okay, so these are all some of the practical units for measurement of length. Next are some of the practical units for measurement of area. 1 acre. 1 acre is equal to how many square meters? 4046.8 square meter, and 1 acre is equal to 40 kuntas. 1 hectare. These are the largest units of area, measurement of area. Okay, 1 hectare. 1 hectare is 10,000 square meters. Okay, area na, so we'll be calling it as meter into meter, length into length, meter into meter. So it will be, we'll be getting meter square. So 1 hectare is equal to 10,000 square meters. Again, some of the practical units for measurement of mass. 1 metric ton is equal to how many kilograms? Generally mass is measured in kilograms. Kilogram is the standard unit of measurement of mass as per SI units. Okay, so 1 metric ton is equal to 1000 kilograms. Generally metric ton is used for the measurement of steel bars and many other materials. 1 quintal is equal to 100 kilograms. Okay, we say 1 quintal. Okay, 1 pound is equal to 0.454 kilograms. It is less than 1 kilogram, half of 1 kilogram generally we say. Generally a newborn baby is how many pounds? Maybe 4-5 pounds, we say that. Okay, again 1 slug, this is used for crops. Okay, 1 Chandrasekhar limit, 1.4 into the mass of the sun. Okay, it is the biggest practical unit for measurement of mass. If people ask what is the biggest practical unit for measurement of mass, then it is the Chandrasekhar limit. Okay, so once you go through this slide, pause the video and go through this slide. These are some of the practical measurements for mass. And next, some of the practical units for measurement of time. One solar day is 24 hours. One day is 24 hours, right? And once generally, how many hours in a day? We say 24 hours. So one sidereal day is 23 hours and 56 minutes. Okay, for one revolution of for one rotation of the earth, it takes 23 hours and 56 minutes. One solar year is 365 solar day. Okay, 1 year is equal to 365 days. One lunar month. Okay, one lunar month is 27.3 solar day. Okay, once you go through this slide again, these are the seven dimensions of the world. Length, we use the letter L in brackets. Okay, dimensions, we generally we use them in close square brackets. Mass, M. Time, T. Temperature, K. Current, A. Ampere, na? So A. Amount of substance, N. And luminous intensity in J. Okay, so what are the dimensions of a physical quantity? Okay, so the nature of a physical quantity is described by the nature of its dimensions. When we observe an object, the first thing we notice is the dimension. In fact, we are also defined or observed with respect to our dimensions, that is height, weight, the amount of flesh, etc. The dimensions of a body means how it is relatable in terms of base quantities. How we define the dimensions of a quantity, we generally define its identity and existence. It becomes clear that everything in universe has dimensions, thereby it has presence. So dimensions of a physical quantity, or the dimension of a physical quantity, is defined as the power to which the fundamental quantities are raised in order to represent that quantity. Okay, so we will discuss about dimensions of physical quantity in detail in our next video. If you like my video, please like, share, comment and subscribe to my channel. If you have any doubts, please post your doubts in the comment section. Thank you.